Now let's do this question. The question is relative sort array. You can see it's easy level question. And then I would say this question is very frequently asked by the big company. So you can see here. And then now let's do this question. So here we have two array. In the elements of array 2 are distinct. And all elements in array 2 are also in array 1. Okay. So now we need to here say sort the array of array 1 such that the relative ordering of the item in array 1 are the same as in array 2. Elements that do not appear in array 2 should be placed at the end of array 1 in ascending order. So okay, now how to do that? The question say the array 2, all elements in array 2 are distinct, right? And which mean the here all the elements should be in the array 1, but array 1 still have some elements that array 2 doesn't have. Now we need the rest elements need to be sorted in ascending order. So now how to do this one? So actually we can there are two ways, two approach we can use. The first one, beyond the question we need to count the frequency of each number in the array 1. So we here we have hash map or bucket sort. I suggest using the bucket sort here because bucket sort can count the frequency of each number, and in the meantime also can sort in ascending order. And then the time complexity is B of n. So I would say this is very, very good solution for this question. Now we have this table. We need to count the 2. We know the 2 we put it in the never start from index 0, 1, 2. Index 2 store the value only store the value. So you can understand this one is the index and the second column is the frequency. And this one is frequency. So now we know the 2. We need to count how many 2 we have. It's 3, right? So now 2 occurs 3 times. This one is frequency of 2. Now here, the 3 occur how many times? 2 times, right? Now 1 occur 1 time. And the 4 occur 1 time. And the 6, 7, the both number occur 1 time. So 6, 7. So between the 4 and the 6, we still have 5. But in the table, because it's just table, right? So you hopefully understand here still have 5 between the two number. And then the 6 occur 1 time, 7 occur 1 time. No, what about 9 and the 19? Okay, both occur 1 time, right? 19 occur 1 time. Now let's come back to here. We already stored the owner's number in the table. Now we need to go through here, go through this array 2, because the return array should be following this order, right? And then if we still have elements left in the array 1, and then we should be adding the last elements to the array in ascending order. So now we know. Now you can understand here is our return array. Now here we go through here. Now 2. Now we go to this index. Okay, we found out the 2 occurs 3 times. Right? So now we here put a 2, 2, 2. Now here we already complete. We use all the 2, right? Now here should be put a 0 here. And the same. Now we're moving our pointer point next number is 1. how many one we have? It's just only one, right? One. Now here also become 0. Now 0.24. 4 also occurs one time. So now 3. How many 3? We have 2, 3. And then here's be 0. And the 4 also becomes 0, right? Now we go to 9. How many 9 we have? It's 1, right? And finally it's 6, right? How many 6? It's just 1. So now needs to become 0. It's 6. Now after here, do we complete the array, return array? No, right? So we need to check. We need to go to the table one more time. Let's see if there's still some elements left, right? So now we need to add these left elements to our array. So we can see it's 7. 7 and the 19. We need to put these two numbers in our array. So you can see here, right? We already sorted. So we just go through we just start from the first index and to the end. Now we can add a smaller number first. So I would say that solution is a very efficient way to solve this question. Now let's come back to here. So we can create array. Maybe we can call count. Now we need to, you can see here, you can see in the constraint is the maximum number is 1000, right? So now we can create the size is 1001. Now the first step we need to go through the array 1, right? And the array 1 length. Now we need to count array 1. So now which the statement means we need to count the frequency of each number. Now we finish this one. We need to create we need to go to this array 2. Now we need one more pointer. Okay, because we will store new elements into the array 1. We don't need to create new array. It's up to you. Actually, you can also create one more array here. Also, you can directly working on the array 1. It's up to you. Yeah. Now we need to check and count array 1 I if greater than 1, greater than 0, which means they have number in there, right? So now we need to array 1 k plus, and we need to put the array 2I, and then here we need to copy this one, decrement by 1. After here, we need to check the array one more time. So let's see still elements left in the count array or not. We can put 1001. Then we need to while loop do the same thing. So new count I is greater than 0 or not. If yes, we need to array 1 k plus increase by 1 equal to I. So now finally we need to return array 1. Now let's run it. Oh, okay. So now we go through this one. Okay, here I forgot to decrement because we already used the frequency. Now we need to decrease the frequency by 1. Okay, you can see it's passed on the test case. Now you can see is 100% here. I think why here is 100% because I use the Bucky sort. If we use the hash map, after you store the elements in hash map and then you need to sort it. So then you will use the much many data structure there. So I would say use many additional memory there. So that's why. So using the Bucky sort is best solution here. And then thank you for watching this video.